Here for today is Joey Lee, who is a alumni of 2018, and she's donating her time to us, and thank you so much for that. She's been an intern at JPL, and I believe this was early this year, sometime in January, or I don't know when it was. I thought I saw her, and I said, "Wait, let me send her an email." I thought I was seeing things. I'm getting old too. But and it was her. She responded, "Yeah, I'm at JPL interning." It's like, what? She was in front of my building, so we talked and everything. And so I asked her, "Hey, can you, at one point give a talk to our kids?" And I said, "Oh yeah, I'll be glad to." So here we are. Thank you so much for joining us.
Yeah, I just want to
Take it
say
away.
first of all, thank you to all the students for being here. I know that it's a Saturday, you don't have to be here, so you'll be listening to me talk for the next hour. So I hope you'll get something out of it. And then huge thank you to Mr. Palta for putting this on. Like he's done a lot of work just to get all of these speakers up, so definitely thank him if you can. So just to start off, I'll basically be talking about my experiences just like these past 2 years in college, I guess, at my internship and at my research an opportunity, just like sharing what I've gone through, some tips, and just some like cool things about the places that I've been at. So just like a brief intro of myself again, my name is Joey. I'm currently a third year student at MIT studying computer science and engineering with a planned minor in brain and cognitive science or neuroscience. And on campus, I'm involved in clubs like Women in EECS, TechX, which is a student organization mainly focused on empowering students in technology. I was part of this group called X Fair, where we hold this career fair um, in like the winter slash spring time, just for students to really interact with recruiters and hopefully get a internship for the summer. Also involved in my house government, help plan the CPW event, which is basically the event in the spring where prospective students are like, do I really want to come to MIT? And then when I was at Oxford, I was part of the STEM club where I was president. I think it has rebranded as of now. Also participated in the Cyber Patriot program and was on the varsity girls tennis team for 4 years. It's really crazy because I'm looking at this, seeing like class of 2018 alumni. It's like, wow, I feel kind of old. I probably am the youngest speaker you guys will see, so might not have the most experience, but hopefully we'll have a great time today. So first, I'm just going to talk about kind of my time at JPL. I was an intern there for the summer after my freshman year, and then because I had such a great time, I came back for a mini kind of internship this past January. So that was like a year ago, just doing like a 4 week kind of continuation of what I did during the summer. And that's when I met up again with Mr. Peralta. That was really crazy. But yeah, just a brief overview of what my internship entailed. I was part of the cyber defense and engineering research team. Before coming onto this project, I kind of had like a little bit of experience in cybersecurity, but nothing too gigantic. So I was definitely a little bit overwhelmed and not unsure if I would really succeed in the role. But my mentor was super helpful throughout just the entire project and beforehand, like onboarding me. And so that was a really useful thing to have, just my mentor being there constantly for me. So I worked on the CyberSam project. And so the CyberSam project really helps in improving mission situational awareness by detecting, diagnosing, and responding to cyber threats through data collection, analytics, and visualization tools using this sort of technology called Splunk. I don't know if any of you have ever heard of it, but basically Splunk is this sort of application where you have a bunch of data, you can basically build queries and produce graphs, tables, any sort of like diagram where the information makes a little bit more sense than just seeing all these numbers. And so at NASA, for NASA's missions, like we constantly have a bunch of data coming in and being forwarded daily. And so this kind of makes it nearly impossible to really glean like what is really going on without certain tools. And so with these sorts of dashboards, the mission end users can really tell like what is going on with the host. And if there are any anomalies, then they can take the action to make sure that everything is still safe and sound. Um, my project was really split into, I guess, like 3 different phases. The first phase was going in and seeing, okay, like what is CyberSam? What is this group? Like, what am I doing? What is Splunk? because as I said, like I had no experience whatsoever, and so the first phase was just like mainly just being comfortable with what kind of technology they were using, and then just absorbing that. And then the second phase is working on improving the workflow of the sort of current dashboards that they had. And then after that, I was able to implement my own detector itself, which focused on analyzing anonymous listening points. And I'll get into that later of what that means. And then my last bullet point here, I said like thinking like an attacker. I think this internship was really unique because before it's like, okay, you always constantly use the internet to, I don't know, let's say like write your essay, play games or whatever, but you don't really think about the things behind what is going on in this process and like what hackers can really do. And so in order to like really be in the mindset of a like cyber defense person, you also have to think like, okay, what is the attacker going to do? And then I have to kind of like push back on that. So it's like really this like game of cat and mouse, and you're taking both perspectives. So it was really a really interesting thing to take on. So when I first joined the project, we had this sort of, you see these three graphs on top here. This is part of the authentication dashboard. And they really wanted to create something that would accompany these current graphs just to show more information. So for instance, as we see here, this first one, excessive failed password valid user, there are three users here in green, blue, and orange. And we can kind of see like, okay, this is happening from July 1st to July 9th, and this green person has a lot of excessive failed passwords. This blue person has also a lot, like under around 20, which is a constant line, which is kind of weird. And then this orange user has like this one little spike. But we can't really tell like, okay, so is this green person like how often are they doing within a certain time period? Because your graph is only so big, and if I want to zoom in more, you would have to click into this query and kind of like dig into that. And I guess like same thing also for invalid users, and then looking at the failed passwords, these are looking at where these people are coming from. So for instance, like what is their source IP? And so from here, I constructed this down here, this failed password diagnostics table to basically accompany these present graphs where it displays the anomaly start and end time, the duration of their sort of presence within this time period. So this person is here for like almost 13 days. The number of failed attempts within this time period, what user they are. I whited out some of this stuff just to make sure that I don't get, you know, the source, fully qualified domain name, source IP, and then which target host they are trying to get into. And so this table is mainly meant to supply information in conjunction with the three charts at top. So for instance, if I'm concerned with this green user, like, okay, what are they doing? Then I can go look at this table, find this green user and see like, okay, they are targeting this certain host over this many days. And so this table is broken down into, what do you call it? They are separated by host. So for instance, down here, you see there are two Joie Lee users, and they are targeting two different ones. I think there was no host corresponding to this target that they were targeting. But as you can see, like Joie Lee has attempted 4 times within a time span of 1 day for this one target, and then another time for a certain one. And so from here, you can kind of have a better idea of what a user, we don't really call them an attacker yet because we don't know what their intentions are. So we'll just say this sort of user, what they're trying to do. And so this table might seem like super simple looking at it, like, oh, like I could definitely bring that up in like, 30 minutes or whatsoever. But what was really the beef behind the work for this table was thinking like how the information should be arranged. Like what information should I display, and like how do I get the information from events? Because when you first build a Splunk query, you have like lots of columns, and so you have to figure like, okay, I'm only going to look at, let's say, the end time, start time. I'm only going to look at the user. So you have to pull those down, and then from there transform it so that it is what you want it to look like. And so the final product that we see here is actually not what was originally created. I had some sort of like beta version of this table, and then we had like this mini sort of demo at this CyberSam user group meeting, and then I presented that work, and then from there some people there gave feedback and said, oh, I would like to see, instead of just the source IP, I would like to see the corresponding domain name tied to that IP address. And so from there, it was really nice because I got to get feedback and then right away sort of reiterate on the work I had done. And so by the end of that, we kind of see what we have here, which is this failed password diagnostics table. And so it's really nice because my mentors had to reach out to me and said like, hey, we've been using this table a lot, and it actually helped us to catch like, oh, is this an anomaly or is this an attacker or not? And so I think what was most significant about this sort of initial phase of my internship was really, like I said before, adopting the mindset of like trying to anticipate corner cases and roadblocks. So initially I was like, should I be really focusing on the duration of the attack from one login attempt or focusing on the time frame? And shouldn't an attack duration of 10 seconds be compared to one of like 1,000 seconds? Like this right here, the duration, whoopsies, my bad. Duration of the days, it's like, should I display in hours, days, minutes, or seconds? And so I was able to create some sort of query where it would dynamically translate, like if it's greater than, like, I don't know, 36,000 seconds, it would translate to hours or days or whatsoever. And then the last part of my internship was kind of building a new detector itself. So that password diagnostic table we saw previously was accompanying the authentication anomaly detector. This one is going to be a listening ports detector. And so what that means is, let's say you have a certain host. We basically want to diagnose any weird ports that show up as listening on it. So if you have like a lot of open ports on a certain host, that could serve as a risk because attackers can potentially bypass the firewall and, let's say, like travel through with an port and essentially gain control of your system. And so immediately I thought of a separation of two kinds of anomalous ports. Um, there are some ports that should not be open on a mission host whatsoever. Like they are known to be either unsafe or attackers have used those before and we don't want those to be open. So those have like a higher severity. Now there's this other kind of port where, let's say, we have never really seen it open before in the past 30 days. And so we should kind of be cautious on why it all of a sudden just opened and kind of like flag that. So for instance, if you are on your host and you see like all of a sudden this port like 1, 2, 3, 4, 5, 6 all of a sudden open, you're like, that seems a little bit fishy because I've never seen it before. And so we would categorize that as an unknown port. Whereas before, when I was talking about the high severity ones, we categorize those as unauthorized ports. And so I think for the portion of in the like beginning phase of just drafting what this detector would outline, we really had to differentiate and kind of like cement what kind of terminology we would use for these anomalous ports. So unauthorized ports are ports that have adversaries have targeted in the past, and it can be split into common and uncommon. So common ports might be like port 80 or 443 or 22, which you guys might know as like HTTPS or HTTP, while uncommonly used ports are non-standard ports previously used by hostile groups like Poison Ivy or Cobalt Strike. And so one thing to note here is like while port 22 and 80 are common, attackers can take advantage of this fact to really blend in with the normal activity and slip by unnoticed. So to catch these sort of unauthorized ports, we created a blacklist for these commonly and uncommonly ports, commonly used ports. I know I'm like using these words a lot and it might like sound that they are intertwined with each other, but I think in my next slide, it will really differentiate what I'm talking about here. And then for the unknown ports, so the ones where like 1, 2, 3, 4, 5, 6, or like 99999, where we know they're probably not super unsafe, but we've never seen it before. We also created this sort of whitelist, so different from the blacklist, where it would look at a baseline of what kinds of ports we've seen for this mission in like the past 30 days. So for instance, I looked at the host, the port number, and the protocol from the past 30 days for mission, store that within some sort of CSV file, and then updated it as like a sliding window. So if we're looking at, let's say we're at April 30th, we would look at the past 30 days information and see like, okay, has this one record been seen the past 30 days? If yes, then it is considered safe. If not, then we will show that on the dashboard and we will label it as unknown. And one thing to note here is that we might have a lot of false positives. So port communication over like port 22 or 448 is super common. Like you guys are doing that. It's up if you go and look at like your network activity. So attackers definitely can evade notice just because they're communicating over like these normal ports. And so to counter this, we worked with mission end users to create a whitelist of accepted hosts for common ports. So for instance, if port 999 should be open on certain hosts, like we know that that's definitely okay, then we will say, okay, we'll put that on our whitelist. And we do that comparison from incoming data to our rolling window. If it's also on the whitelist, then we can say, okay, that's safe for now. And so this is kind of the tables that I drafted for the detector. So the first one that we see here on the top left is the unauthorized common ports. So those ones are common ports like 22, 80, 443, that sort of thing, 25. Unauthorized uncommon ports, those ones would be the ones that have been known that attackers have used in the past. So good thing that we don't see any there for now. And then these ones down here are just showing the sorts of ports that have been open in the past 30 days. So if you're interested in seeing like, okay, what is really part of my baseline, then you can see the host, the port, and the protocol looking at there. And it's definitely like this, I guess like solution cannot catch attackers with 100% certainty. Like anomalies may or may not indicate malicious intent, and so it's kind of hard to decipher whether an event should like we should label a certain event as like, oh, this is an attacker or not. But after my work building this detector and I left, we discussed kind of like what kinds of things we will be looking to kind of add on top of it in the future. And so with these anomaly detection, it's really helpful to sort of create a kind of story. So, for instance, if I see that a user called Joie Lee tried to go into certain hosts and had a bunch of access failed passwords the same time that a bunch of weird ports all of a sudden open up a certain host, then this might indicate that a sort of attack is happening. So trying to like draw a correlation between different events. And so that's like really the main goal, which you can kind of build by maybe using like machine learning or something else. And so what I implemented in my time there was really just a crude implementation. It definitely got the idea starting of like what we should do for a listening ports detector. And so I think it was just a really fun project overall because I got to think in that mindset of like an attacker defender, gain more experience in Splunk, and really gain some more knowledge into like what life is as a cybersecurity engineer. So these are just like some of the project takeaways that I had working that summer. So design plus thought is greater than implementation. Like a lot of the times, especially like at school when you're doing labs for like coding classes, you're like, okay, I just want 100%, 100%, 100%. But in real life, when you're working on an actual project where people are using it, you really have to think about like, okay, what am I going to like? What is my outline going to be? And like for the people who are going to be using my project, how will I make it in a way where it's easy for them to use? So for instance, like with this ports listening ports detector, I had to pull data from missions like M2020, mission like MER, where they had differing numbers of hosts. Like M2020 has a lot more hosts than some missions that have already been phased out. And so in order to build these queries, you have to go through all of those hosts. And so the runtime for certain queries might take way longer if you have a lot of more hosts. And so you have to think about that sort of performance kind of measure. And for the data, I had to think, okay, what is important, what is not important? Like, what do the mission end users really want to see? And so that idea of like creating something for people instead of just for yourself was definitely a shift from like regular school project work. And then the right here, just some sort of the technical things that I found helpful was learning the Splunk search processing language, contributing to a project from like just an idea to the actual um, end product and working like with version control using GitHub and actually deploying it to missions at the end of my internship was super awesome. And mentors like updated me saying like, hey, yeah, like we have used this for certain missions and we have found things, which is like really, really heartwarming. Like when you can actually create something that people are using, that just feels really, really nice. And then the last thing here, life as a cybersecurity engineer, it was, I never thought of that as like a career field before, but it was definitely really interesting to be able to work in that environment. And then at my time there, definitely it was really awesome being able to be on lab. This is, I believe, a replica of Curiosity. And then also, I was also there when they had the 50th anniversary for the moon landing. It was a really, really awesome time. We had like this like stamp event. There was like free popcorn, all that stuff. And then this was in mission control before Perseverance was launched off. So it's really crazy seeing that now. That number is negatives or whatever you call it because it's been over a year. And then this is actually Perseverance itself before they shipped it off to Florida. And so we were like in this sort of cage looking in. So that was really awesome. It was also mind blowing. It's like, wow, like I got to see that before it's going to be shipped off
That's a
to.
clean room in one of the high bays.
Yeah, yeah. It's just really like mind blowing being on lab. You're like, that is happening right in front of you. Like it's definitely an experience you cannot get anywhere else. Like JPL is definitely one in a million. Like it is just so cool. I can't emphasize that enough. Like Mr.
Right.
Papa, you
I
have
feel
to
the
job.
same.
Yeah,
I've taken pictures out of it.
yeah, that was
Took a lot of
definitely
pictures.
a summer to remember. It was an awesome time. I would definitely recommend if anyone has the opportunity to like intern at JPL, like do it. Like you will not regret it. And so that was my freshman summer and sort of like my winter internship. This past summer, I joined Salesforce. My reasoning for that was that I really enjoyed my time at JPL, but I really just wanted to try something new. And my mentor supported me all the way. I think that as a college student, if you really do find that you are at a place where you love it and like you want to stay there, maybe for like the rest of your career, like go ahead and do it. But I also think it's really helpful to just explore new places, gain new skills, meet new people, and just sort of like be in a different environment where like you just might try out a new thing. You might not like it, like that might suck, but I think that trying new things is always like nothing can go like you'll gain something out of it. And so I joined Salesforce this summer. Unfortunately, because of the COVID situation, I was really looking forward to visit San Francisco, but that didn't happen. I was a remote intern, so just working from home for 12 weeks. So I joined the tools engineering team, and I worked on a project called Blitz as a Service. And my project revolved around basically taking this sort of like project and operationalizing it, so bringing it into production, building a UI so that people can interact with it, and testing that application itself. So Blitz is, I think, a term that is kind of just used internally within Salesforce. So I'll explain what that is first. So a blitz is basically a time where a bunch of engineers go into a certain application and basically do a bunch of operations just to make sure that the application is working fine. So in basic unit testing, we would probably already have made sure that like, let's say the UI already looks fine. If I click a button, like, okay, that works. But now within a blitz, we want to perform exploratory testing. So performing operations like, let's say in a sequence, if I click a button, enter in some sort of input, hit enter, refresh the page, that sort of thing. And so that's really what a blitz is. Now, what my project revolved around was um, automating this process where you would pull data from what was happening in the blitz. So, for instance, how many users were in the blitz, how long they spent on a certain page, what things that they clicked, how long a certain page to load, that sort of thing. So, like, kind of the I guess like performance measures of what happened during the blitz itself. So the code to like automate that entire process already lived within a certain host and was already up on GitHub. But in order to run that process, like if I was person X, Y, and Z, all of us would have to manually pull that code from GitHub, run it on our own machine, which would take, let's say, like 10 minutes itself, and then finally be able to look at the end product. And so what I wanted to do was basically move this code onto a server, create some sort of application that users could go to, let's say like a website. They could go to this website, fill in the information, click like go, and they would perform the blitz for them. So in a way, it's like abstracting away all of this process you need to like pull it from GitHub, install it on your local computer, and doing all this stuff. Because some of the people who are concerned with the blitz, like they are not technical, and so they would not know what to do like with this GitHub thing or how to install it on their own machine. And this project was written in Python by some dude in another team, and he kind of just like left. And so when I came onto the project, none of the people on my team knew Python, which is definitely kind of jarring because I think like at school, like you do Python constantly, like, oh yeah, everyone knows Python. Like, how can you not know Python? But here at Salesforce, the main language is Java, and so no one really had any experience with Python. So I kind of had to, I just like shoulder all the burden of making sure that everything was working perfectly myself. So the first issue was mainly just getting this project and moving it onto this remote server. And what really sucked was that this remote server lived in an environment where there was no network connection. There was no pip, which is the default like Python package manager. and it was using Python 2.7, which we do not like because we are currently in Python 3.7, and Python 2.7 is really outdated and no longer supported. And so I had to figure out a way to like basically bundle up this whole entire environment, which included like Python shell scripts, some sort of Anaconda environment, move it onto this remote environment and make sure that the project still worked without internet connection. And so I looked into things like Python wheels, creating dependencies for the project remotely, and then shifting that all up there. So a lot of just like research stuff in the beginning, and they kind of expected me to like know all this stuff beforehand. I was saying like, hey, like I don't know any of this. I communicated that right away. Like I don't know any of this, but I'm going to spend some time to make sure that when we do move all of this stuff up to the environment, everything is still a-okay. So that's one of the big things I found in this internship is communication, especially since we are in a remote setting. I communicated with the mentor just like through a video chat or through Slack or whatsoever. I couldn't just like go up to his desk and bother him and be like, hey, like, can you help me with this? And so communication was such a big thing in this internship. Just always conveying like what you're doing right now, what problems you're running into, and what you're planning to do in like the near future. So after I got all of that code onto this remote server, we were able to build some sort of front-facing UI so that people can interact with this Blitz as a Service project. I don't have any like pictures or demos as to what that looks like because it was all on my work computer, which I do not have anymore. But just to give you an idea of what it kind of looked like, it was just a simple front-facing application where you enter in, like, let's say the name of your blitz, the date it took place on, the time period, and then some sort of other filters that are not really important to discuss. And then from there, you would click go. It would perform the process to pull all of the like CSVs from Splunk. And then from there, I was in charge of presenting the data in a way that would satisfy all the users. So for instance, I have all this data from Splunk concerning like what is going on during splits, but I really have several different target audiences and they all want to see different things within this Jupyter notebook. So for instance, if I were a manager, then I would probably be concerned with, okay, how many people are participating in this blitz and which people are kind of doing more things than others. So for instance, if like Joey Lee only visited one page in this whole blitz and I see like user Josh visited like 10 pages during a blitz, I would think like, okay, it seems like Josh is doing more of the grunt work than Joey is. So I should probably go talk to Joey and be like, hey, what were you doing during that blitz? Whereas if I were an engineer who was in charge of the blitz, I'd probably be more concerned with which pages loaded faster than others. Like if this page took like a whole 2 minutes to load, that might mean that there's something, some sort of process within that page that's like holding certain things up. And so they're really different, different like target data metrics that different groups of people were looking for. And it could be that one also has more technical knowledge than the other. And so actually, I didn't explain what the Jupyter Notebook thing is, but if some of you haven't worked with Jupyter Notebook before, what that basically is, it's this service where you can create tables, graphs, or whatever using code like on live. And so it's really cool because I can like code up, say like I have this, let's say like Panda file, and I want to create a plot of like time versus count. I can do that right away in the Jupyter Notebook and it'll bring it up. And so I created this Jupyter Notebook showing all of these different, I guess like data metrics serving different goals for different people. And it was, I thought it was during my time, it was definitely hard trying to like take on this perspective, trying to like satisfy all these different people. And so throughout the internship, I had a lot of demos just showing like, hey, this is what I have so far for a certain group. And they would give me input as to saying like, okay, like this is good. I would like to see more information concerning this portion, or like this graph, like that's not really necessary. Like we don't really care about that sorts of things. And so once again, the idea of getting feedback, reiterating on what I had currently, and just updating like the product of what it was to essentially just making it better and easier for people to understand. That was a huge thing that I found in my previous internship and also in this internship. Just always being sure to have like the customer in mind when you are creating whatever project, like because even though you're working on this project 24/7, you probably know it like front to back, like it is your baby. Like other people who come onto the project, see it and use it, they might not know what is going on. And so just always making sure that um, what you're creating is not just for yourself, it's for people who are using this product actually. And then one of the issues that I also faced within this project was Jupyter Notebook, it by default runs on your local host. So if I run my Jupyter Notebook process like on my terminal right now, like I can see it, but if like my coworker wants to also look at it from their computer, they cannot do that. And so I had to look into running Jupyter Notebook off a public server so that we translate it into some sort of different URL so that any person within the network can go onto this page and look at this Jupyter Notebook and see like, oh, okay, like that looks cool. Scroll through, see all these data, all these tables, graphs, and that sort of thing, and be able to draw information from it. Also, what I learned from this internship was kind of working in this agile framework. I think agile is kind of like this buzzword that's been going around within like software development teams. You guys might or may not have heard of it in school. I feel like you wouldn't have. It's something you hear more of in industry, but it's just basically this process where you are working in like, let's say, a small group, and you have sorts of, I would say, like goals that you need to accomplish, and you kind of have to prioritize like, okay, like which one is my team going to finish within this sort of time period. For my group, I think we worked in a sprint process of like 2 weeks, and so in the very beginning, you would say, okay, these are our um, targets for the 2 weeks, and by the end of 2 weeks, you should have completed it. And then throughout the process, you constantly meet with your Scrum Master just to make sure that everything is going well and that things are basically on track. For me personally, I think that our team didn't adhere to like this process very much in the sense that like it wasn't like super priority. It depends on like which team you're on. Some of the teams, like some of the interns I talked to, they lived by the Scrum process entirely. Like it was kind of like the holy grail of what you should follow. But for my team, it wasn't that case. But I think it's really interesting just to be put in that environment and to see like, okay, like what does working industry actually feel like? Because at JPL, it definitely had a sort of different vibe, especially my team. It had more of kind of like a research kind of setting, which was really fun. But here it's mainly about, okay, like we are pushing out this sort of product and reiterating on that. So it's definitely a different environment to be working in. And just some of the takeaways that I had from this project was, as I said, adopting the view of the customer, building stuff that we understand by all. Oh yes, documenting your work. So as I said, I was the only person on the team who knew Python. So when I left, um, this meant that the current team had to know like what I had done and be able to replicate my work. So I had to make sure that everything that I had built, I included a like separate documentation for like how it works, how I did that sorts of thing, so that someone else who would take on the project would know what to do afterwards, basically. And then last thing here, ask for help. That was a huge thing, especially being in a remote setting. Um, if you run into a problem, you can't just run to your manager or supervisor and be like, hey, like, can you help with me with this line of code right away? Like, no, that's not the case. You might be stuck at home. You might feel discouraged. Is like, what do I do? And so just pinging my mentor, being like, hey, like I'm stuck on this, and he got back to me right away. It was just really helpful in just, I guess, like relieving any stress that you could have potentially had, or just like cutting down any unnecessary time you could have spent on a certain problem. And
Joey, I just want to add a comment about that. Is that it's good to have an engine, so to speak. You know, you document everything what you do, right? And so it can be duplicated or what have you, or for troubleshooting purposes. So I always stress about in an engineering book for our team. Remember in the past, so we're still trying to do that. But
yeah.
I believe we have a better handle this year. Uh, I believe um, I think a couple of people are keeping up with that and they're keeping their notes and so forth. I think the business team and then our leads um, are doing that as well. So
Yeah, documentation is such an important thing. Like, let's say you're working on a piece of code, it's equivalent to like writing comments. If you don't write comments, like no one knows what you're doing. So yes, please document your work. That's a huge, huge tip that I want to share.
thank
Lastly,
you.
ask for help. Don't be afraid to ask questions from your mentors, teachers, or whatsoever. Like they are there to help you. You are not a bother. It is not a dumb question. There's no such thing as a dumb question. That sort of thing. Always ask for help if you need it. People don't want to see you fail. Like that's bad for you, and it's also awkward for them to be in that situation as well. Yeah. So
Thank
that
you
was
for doing
basically
that.
my summer at Salesforce. So this is like the Salesforce Tower. I'm so sad because I wasn't able to visit. I've always heard such good things about like gummy bears and those sorts of things. So I'm really sad. But hopefully, maybe in the future, I'll be able to walk inside the building at least. I think they're still under lockdown. No one is in the office yet. But the internship program itself was still run super successfully. We had a lot of events that were put on virtually. Also, I got to attend this sort of like pottery making session because Salesforce, one of the big things at the company is well-being. They really care that their employees are safe, like physically and mentally. Like mental health is such a big thing, and so they have these sorts of programs to basically help you reimburse anything that you want to do concerning well-being. They have a bunch of like yoga sessions that they do online, which is really really awesome. And of course, one of the biggest things from the Salesforce internship is getting swag. I have like literally a whole wardrobe of just Salesforce stuff. It's just really funny because they just keep on saying it's like wow, like this is crazy. I wasn't expecting all of that to happen, but definitely thankful that I am now equipped with a whole Salesforce outfit. And then one of the last things that I'll be talking about today is this research project that I got to take on this past summer, actually with my mentor from my first JPL internship. So when I was on the cyber defense team, so we have been like, just constantly keeping in touch. He's always been like there for me, just offer like career advice, school advice, life advice. I think that maintaining a close tie with your mentors, your teachers, it's just always super helpful because they've gone through like life itself already. They know what you're going through. They've gone through already, so they're always open to helping you and just giving advice. And so in this case, he presented to me this opportunity to basically take on this project to explore some aspect of machine learning, which I had some interest in. And so we kind of just started that this past summer, albeit remotely. And so I'll just be talking about what the project is, some of the things I've learned, and that sort of thing. So the problem itself is that within the cybersecurity community, um, the idea of using machine learning to detect anomalies is kind of like gaining more popularity. But as we know, for machine learning, like data is essential. You cannot build models without having data. Um, but as of now, a lot of the data that is publicly made available to like the research community is either of low quality or there's just not a lot of publicly made available data. Like people will either have privately made data sets just because of security and privacy concerns, or they will create sort of synthetic data that's of low fidelity. And so we wanted to explore the use of machine learning to essentially generate synthetic data sets that are still of high quality. And so we wanted to do that through using something called a generative adversarial network, otherwise known as a GAN. So that was just mainly the project outline that he proposed to me. And so in the beginning, I was like, oh, okay, like I don't know what GANs are, but I really want to explore how machine learning can actually be used. Like I had taken an intro to machine learning class, but that was kind of doing like theoretical work. Like I didn't really know what that meant, like actually building a model. And so I was interested in what that would entail. And so we just kind of started the project off from there, from this sort of idea, just not knowing anything. And we wanted to basically tackle this problem. So right off the bat, I was like, okay, like what now? I didn't know what to do because it was just this huge problem. I didn't know what GANs were. I'd never really done any sort of like intense research before. This is like my first kind of like research experience. And so I was just definitely confused at first. Also as being remote, so I was like, okay, like when, like what should I do? So the first step in this whole process was just looking at like what are GANs and what have people done with them before. So this picture right here, it's just a picture of people's faces, right? But actually, like these are not real faces. These are faces generated by GANs. So I think like this second one on the top left, it kind of looks like Beyonce to me. Like I think that's where they got it from. I'm not sure, but these are all faces, like fake faces generated by a GAN, and they look like pretty realistic, right? Like you cannot tell that that's not a real person. So that's super cool. Um, this is also another application of GANs where you have a picture of of zebras, and let's say you want to translate them into horses. Then the GAN can take that picture of the zebra, like get rid of the stripes, and output this picture on the right. It's a little bit blurry. You can tell like the quality is not of like high caliber, but it's still like kind of accomplishing the task of outputting a horse. And then on the bottom, we have a picture of a horse, and we want to put it into a zebra. And so it adds the stripe to the horse, and it's like honestly pretty realistic. Um, so I did a pretty good job of doing this like image to image translation with the help of a sort of like text keyword. Also, this is another, I think this is called StatGAN, I believe. Yes, this is StatGAN. So basically, the input to StatGAN is this sentence that we see here on the top. So the small bird has a red head with feathers that fade from red to gray from head to tail. And the GAN is able to generate an image just from that text itself. So in the top row, we have something called the stage 1 image, where the GAN basically outputs a lower quality image, oopsies, a lower quality image just trying to extract certain features from the sentence itself. So I think right here we can definitely tell it's gathering a red head, um, small bird, and then in the stage 2 image, what's really happening here is it gets the input of the stage 1 image with the sentence again, and it kind of reiterates upon what has already been done in the stage 1 image and creates a higher resolution image that fits to what this text is looking for. Same deal here on the bottom, but now this time with a black bird with green and very short beak. And we see here that on the bottom 2 rows, like it's pretty good at generating those birds. Um, like these are not real birds; these are fake images that the GAN was able to create. And of course, like the data set that they provided was probably it showed a lot of different birds that might conform to this sort of parameter. But as you can see, like the GAN has done really well in outputting this sort of image where it's like it's crazy that some sort of like algorithm is able to learn this structure and output this. And so when I was doing this like initial exploration of like what GANs are, I was just really blown away by what they're able to accomplish. I think machine learning is such a huge buzzword in like the academic community right now, and like I had heard of it as well. So I was like, okay, like machine learning, yeah, that's awesome. But now just like seeing all of these outputs that this GAN was able to do, like I was just really mind blown. Like it's really awesome. And so to dive into what a GAN really is, I have this structure here on the bottom, which might paint a better picture of what is really going on. So GANs are like a rich class of generative models characterized by 2 neural networks. We have a generator and then a discriminator. So down here, this generator, we basically feed in some sort of like noise vector that doesn't really mean anything as of now. And it generates some sort of fake image. So in this case down here, it's trying to generate a handwritten digit. So the bottom, this might look like a 0, 8, and a 2. Now what happens is that this fake image, along with actual real images from your training data, so these are like real images, real birds, real horses, real zebras, whatsoever. This fake image, along with the real image, is fed into this discriminator part of the network. Now, what the discriminator is doing is it's saying, okay, is this fake image real or fake? Now, as the generator, we want the discriminator to say, oh yeah, that's definitely real. Like, we want to trick them. The discriminator, it wants to make sure that it's not classifying a fake image as real. And so our loss is essentially looking at whether or not this discriminator was able to tell whether this is a fake or real image. Now, if you think about it, this is kind of like a game of cat and mouse. The generator is trying to produce realistic enough results to trick the discriminator into thinking like, yes, that is real. And so I think we essentially reach a point, we reach convergence essentially when the discriminator assigns a probability of real fake of 50% to either one. Like it's essentially just guessing whether it's real or fake at that point. And so from there, our generator is probably producing realistic enough data that can pass off as the like real images from the training data itself. Now, the like normal GANs face this problem called mode collapse, where the generator kind of learns this like narrow space of things that it can output where it can trick the discriminator. So for instance, we see here that in this first iteration, the generator is producing some sort of results that do not really look like numbers. They kind of look like squiggly lines. Essentially, it gets better as the number of iterations increases. And eventually, it starts to output only this number, I think 6, because what's happening here is that if it outputs the number 6, the discriminator thinks like, okay, that looks real. And so from there, the generator is saying like, oh, like it thinks it's real, like I'm doing my job perfectly well. And so then it's just going to keep on generating the number 6 because it is essentially succeeding. But from our point of view, we don't really want this to be happening because I don't just want a bunch of images of like the number 6. I want images of 1, 2, 3, 4, 5, 6, 7, 8, 9. Or I want like different images of the birds. Like in the birds example, if it had constantly just produced one bird like all the same time, like that's not really giving us a diverse data set. And so this is a problem that GANs face, and it has been addressed in a lot of papers in the recent past. People have implemented some sorts of measures to basically move away from mode collapse, and we also took that those kinds of fixes when we were implementing our architecture. So this is an example of a firewall record. This is the type of data that we wanted to produce from our GAN. Now, I think you'll notice that there is a lot of difference between what I have shown GANs have been like capable of doing and then what we want to do. First of all, we're not trying to output an image. We're trying to output some sort of like record that has really different fields. So for instance, like source IP, that's not really like a numerical variable. It has numerical variables, but they're separated by like the decimal points. Port number, that is numerical. Protocol service, those are more categorical variables. And so these records are like highly structured. IPv4 addresses, they must range between 0 to 255 within each octet. Port number must range from like 1 to 65,000 something. Protocol, like we have either TCP or UDP. Service, we have some sorts of like discrete values that the service can take on. And so we see that like this sort of data is very, very different from images. Like images are made of, let's say, like pixels that can range in value from like 0 to 255, where it's continuous constantly. But ours is not the case. And so we had this problem of thinking like, okay, like how can we use GANs to tackle this problem if a lot of the work in GANs that has been done already is just mainly with the image domain. So then from there, just an outline of the whole process was we defined the problem, we found some sort of solution to like what GANs can do. From there, we extracted what helpful things those people use in their networks, tried it out on generating IPv4 addresses. If it didn't work, we revisited the problem, tried different things, and kind of just reiterated. So in the beginning phases, we wanted to look at maybe formulating our problem as text generation, because we have like IPv4 addresses that have numbers in them, but they also have the period. So we thought like, okay, like what if we model this as text generation? So as you see on the right, this is a GAN that was able to generate a speech that is very similar to Obama's speech pattern. And if you read it, it actually is actually very similar to how Obama talks. Good afternoon, God bless you, that sort of thing. So they incorporated a RNN into their generator, I believe, and that's how they're able to generate this Obama RNN. But we found that with text generation, we also tried some sort of thing called like PassGAN, which was a deep learning method for password generation. We found that it was kind of memorizing the IPv4 addresses that we had currently. And so as you see on the right, there are some sort of errors that it's having where you have periods on the right place or numbers that are with like outside the range of 0 to 255. Also, like using a RNN, we would also have a lot of repeating numbers. So for instance, we're like 166 across these octets, which is not really representative of what normal network data would look like. So that right away gave us an indication that maybe modeling it as a text problem was not the best way to go. And then we also looked into something called the Wasserstein GAN, which would use the Wasserstein distance during training. And then from that solved the issue of mode collapse. So we also incorporated that into our network. I'll just like run through these briefly because I think it's just more important when I talk about what I learned from this project, not really the details into what was really going on into our network. This is like our architecture that we came up with at the end. We call this CyberGAN. This is, I guess, like not really, you can't glean a lot from this, but we have a generator on the left, discriminator on the right. We basically came up with using fully connected networks for our layers and separating into numerical and categorical variables. And after we generated our data, as was shown here on the right, we looked at kind of like the network structure of our data, and it actually modeled the real data very well, because in a network, usually have like a lot of the same hosts communicating with each other. And so we see that this network on the right is actually very dense, which we want, and it's very similar to what real data looks like. Like we have lots of nodes which are corresponding to IP addresses, and the number of edges is almost like twice that. Number of connected components is also like relatively around the same um, magnitude, and the network density is around the same. So I realize I'm running out of time, so I'll just go through kind of like what my project takeaways are. Research is definitely different from an industry setting. Like, as I explained in the beginning, I really didn't know what direction to take. And in research, a lot of times people are doing their PhDs, which take like almost like 7 years or whatsoever. You don't really know if you're going to get an end result. Failure is common. We didn't know if we would actually get good results at the end. But I think that's also one of the fun things about research is that you basically determine the direction of where you go. You said, I want to try this out for this week, see what happens, get together within your group, share results, and say, okay, like that didn't really work, we could try something else. And so research is definitely very different industry, because in industry, you're expected to, let's say, produce some sort of product, we push it out right away. But in a research setting, you're like reiterating on this sort of idea. You don't know what's really going to happen. You might fail, you might succeed. But it was really a fun time because I got to learn more about just like what machine learning is, and just like be in this like different setting of applying what I learned from school to this sort of like real life problem. So I guess that's kind of the takeaway from all of like the 3 different experiences that I had. I really want to make sure that we have enough time so that you guys can ask me any questions that you have about like any internships I've been on, or my time at MIT, or just like college life in general. So please shoot away any questions that you have.
Thank you so much, Joey. Yeah, we're waiting for questions. Here's one, I guess, from Hannah.
Okay.
You can read it.
Is the process with discriminant similar to deep fake type of stuff? I'm kind of confused on what you mean by that. Hannah, do you want to like kind of just explain what your question is?
Yeah, I was just curious with the Obama speech.
Uh,
Since it was able to generate a speech similar to what it learned from Obama. I was like wondering if it's like similar to not deepfake, but would it's just similar to like those type of apps that could like if you insert like a song, it will like continue the song type of stuff. I don't know.
oh, I see what you mean. I see what you mean. Yeah. So for the Obama RNN, what they did was they inputted some sort of like phrase. So let's say war. And then given that war phrase, the RNN is able to generate some sort of speech that would talk about war. So I don't know if that answers your question, but that's just kind of going over kind of like what their structure really was. It's really cool because I would expect that they have to look at a bunch of Obama speeches already and try to like filter out which ones are talking about war, and then try to generate something very similar to that.
Oh, okay, thank you.
So, I have a question. How long has this GAN technology been?
Oh, I think that GANs were first introduced in, I think, 2014. So it has actually not been a super long time. And when it was first introduced in 2014, like it definitely blew up. People were amazed by what results came out of it. I think it was with like Ian Goodfellow. It was definitely really crazy. They did it on just the MNIST data set, which is the handwritten digits. And so being able to replicate that was definitely a huge thing. And so the image domain work with GANs definitely took off from there. Like I feel like text and other domains, there has been more work done in the recent years, but definitely not as much as images.
Yeah, it's very interesting work. Yeah,
Does this raise
especially with images.
does this raise security concerns?
Sorry?
Does this raise security concerns regarding, like, can you, because if you can do something like this, you can essentially create pictures and text and like basically make a fake person online.
Yeah, so I think there's a lot of ethical problems raised with this, like um, because people have kind of created fake videos that they spread onto, let's say, like social media, and they label it as, oh, like this really happened, when in essence it was just something created, like let's say from a GAN. And also, you brought up a really good point with our GAN, CyberGAN. When you generate IP addresses or file records given fed in data, like that could reveal information as to where that data came from. So for instance, if I am a private corporation and I have a certain IP address and I want to generate firewall records based off my own IP address, then if I make that data publicly available, then people could discern like what my IP address is. And so there's that problem of making sure that when you generate this fake data, you're not really revealing information about where the data came from. But that's kind of hard because like, how do you do that if you're trying to model something very similar to the real data? And so that's the sort of problem that we did not get to basically solve yet, but it's something we want to look forward to in the future. So security is definitely a concern with APIs.
Okay, thank you.
Anyone else? These are really good questions. How many companies and people use your project? Oh, okay, that's actually a hard thing to measure, but I would say that for my detector, it has been deployed on the actual like CyberSam project, which serves. The last time I was there, they were serving around like 10 missions. The biggest being like M2020. There's also Psyche. I can't remember them off the top of my head. Like when I was there, I knew all the missions off the top of my head, but it's been like a year, and so all the acronyms are kind of lost on me. But I have been told that it is actually being used by people, which is super awesome. And then at Salesforce, my Blitz as Service project, they are currently moving it onto their sort of like internal organization stuff. So like restructuring how the project is working, and it's actually serving people, which is super awesome. I think like if you're an intern, make sure that you're not just put on some sort of like sad intern project. Like make sure that you are working on something that is used by people, just because it's really awesome that your product is going to be used by people and you know that it's going to make an impact on others.
This is Mr. Peralta again. I have you work with Anne Rucker. She's in cybersecurity at JPL. I don't know if you ever got a chance. Okay.
Yeah.
I guess there are different sections in cybersecurity.
Probably.
Any more questions?
I'm also happy to talk about like I guess college life if you guys have any questions about that.
Well, so when did you decide to, how did you decide to go to MIT?
Yeah, I think it was not a hard decision for me to make. I'd always wanted to go to some sort of like I guess like tech school where I was able to be surrounded by like such bright minds and that sort of thing. One of the things that definitely held me back was the fact that it's all the way across the country. I guess like being in high school is like always being surrounded by family growing up. It was definitely a huge transition. And so my first year, after that, I definitely felt homesick a lot throughout the school year. And so being able to take on the internship at JPL, being close to home was really a +1 for me. But I think just in the college search itself, I know that I wanted to major in computer science. I know a lot of people, they did not know what they want to major in, but just making sure that I guess like the culture was a fit was also a big thing. I knew that just from like the previous stuff before committing to the college, I knew that like tech and like research and so that sort of like vibe was present at MIT and something that I found was really awesome and drove me to really just like see myself as succeeding there. And I don't regret my decision. I'm really happy here. And yeah, so that's just how it happened.
Right. Did any scholarships play a key role to kind of lure you to MIT, or you had other choices?
Yeah, so I definitely had scholarship help, which because private schools are not cheap. So I definitely had aid from MIT, which was really awesome. But I think my parents like were always supportive of me along the way. They said like, don't really look at the cost. This is something that you will do like once in your life. Like you won't repeat your undergrad studies. And so I think the fact that I was able to get aid from MIT also made the decision easier. But yeah, I think scholarships and financial aid is also a huge factor because college is still at the end of the day, you will get a degree, and no matter where you go, you'll probably learn a lot. So there's also the trade-off of it's like, okay, like prestige versus how much are you going to pay? That's something that you also need to take in mind. For me, it was actually a really easy decision because it was kind of equal playing field, and so from there, it's like I knew I wanted to commit, so it just happened.
Wow, congratulations. Anybody else? Well, thank you so much. I appreciate your time
Mhm.
and stay in touch. Um, and I guess if we have any questions regarding any computer science questions or that, can we contact you or
Yeah,
email you or
so
anything like that?
to answer Hannah's question, I did get gummy bears because they sent us a bunch of snack packages. But if you guys have like any questions about like what I've done at JPL, Salesforce, or just internships in general or college, you can definitely email me at joeylee@mit.edu. And a huge thank you to all of you just for coming out today and listening to me talk about my projects for basically an hour. Always happy to help, so please just shoot me any questions if you have it. And just enjoy your weekend, enjoy your Halloween. Everyone, stay safe, and you got this. Good luck in school.
Thank you so much.
Thank
Appreciate
you,
it.
Mr.